Hello, so this is my first tutorial on manipulating strings. I know a lot of my students are stuck at home right now because of this pandemic, and several of them are working on projects that involve somehow manipulating a string. Maybe they're doing a text-based game, or maybe they're doing something other thing that requires the user to input information and for the Arduino to respond upon that information that's set in from the user. So I thought I would show some of my favorite functions that are used for strings in a single sort of sketch that's going to go ahead and chop up a string. But I'm going to show you, I got all of these essentially from here, okay, which is the Arduino page on strings. And you can see a list of built-in functions that are already built into Arduino. So I'm going to work with about 4 or 5 of these right now, and we're going to play with them in a quick little demonstration. So I've already loaded it. It's ready to go. I will start off by saying that I have created a few variables, globals. Words is ultimately the string that's going to hold the group of words, the entire data set that we're going to manipulate. I am going to be asking for a 4-word sentence in this case, so I want it to be predictable. So I have that broken also up into 4 individual string variables, word 1, 2, 3, and 4, that ultimately that data is going to get parsed into. Num is going to be the variable that holds the total length of the string. Space 1, 2, and 3 are ultimately going to be the index locations of the dead spaces between the 4 words. So let's go ahead and start off with just entering a string. And I'm going to do it a little bit screwed up. I'm going to put a couple leading spaces in there because you always have to anticipate the end user is probably going to make some mistakes. And let's say the mouse ate cheese. Let's see. Actually, I'll make this a capital. Alright, so we made a few mistakes. Oops, I typed it a few too many times. Okay, so there's dead spaces in there. So I have leading spaces and trailing spaces that are going to have to be trimmed out. So I'm going to run it. First thing it's going to do is echo it out. Second thing it's going to do, and I'll show you how this all happens, is it trims those dead spaces off the beginning and the end. Then I convert everything to lowercase. Ultimately, back to uppercase. I could have went straight to uppercase, but I did both. It then calculated out the total number of characters, including the dead spaces, which was 20. It then figured out the positions of all the dead spaces, the first letter after each dead space, and it broke it into the 4 primary words and how many characters each one of those is made up of. And now it stopped again, waiting for me to enter in some kind of a character to be able to figure out how many of those there are in this group of strings, or this group of words. I'm going to type in E. Notice I'm going to use a lowercase because it's going to convert it for me. And it tells me there are 6 E's in this group of characters. So let's take a look at what actually happened with the code, and I'll post this code so it'll be available for you. Setup is very basic. It opened a port. The loop is ultimately going to be going through all these individual functions, and I'll go by them one by one. Dramatic pause, I'll mention, was this here, and actually I'll show it here. Okay, so dramatic pause was literally that. It was just a pause. I just wanted something that would slow this down so I had a chance to read it. So what it did is it printed a single star on the same line every 400 milliseconds, and then when it did that 10 times, it ended the loop and it printed on a new line another new line, so I ended up with 2 dead spaces. All right. Grab string is the very first function that's actually called. That's the one that's going to gather the information from the user. I will say I'm using Chris Odom's skiff, and I'm using the read string function. This is covered in Chapter 6 of Chris Odom's books, but ultimately it can be recreated. It's a matter of gathering each individual character and then sticking it together to create a string from the user input. But it is available as a skiff. So now let's go ahead and look at the very first thing that really happened. Trim it. Trim, like I said, if we go here, trim is this last function provided. And trim does exactly that. It trims it. It gets rid of any dead spaces before and after characters that are not spaces. It does not get rid of the spaces between characters. All right, so it just, the leading end and the trailing end get chopped off when you use trim. So I actually just put it right back into the same variable. This was the variable that we collected the data in, words. I used the function trim and put it right back into the same spot. Boom, and now we have those leading and trailing dead spaces cut off. And then I printed it out. The next two things that I did was convert it to lowercase and uppercase. Again, I used the same variable. I reloaded it. And this is very, very simple to do. You just simply call the functions to uppercase or to lowercase, and it converts all the characters within that group into upper or lower case. Length, very easy to use. All right, in this case, it's returning an integer, which is that variable I created in the globals. And I literally just used the words variable, which is holding our string, and asked it to give me the length, return the length. And it did, and I put that into a string right here. Moving down, how far? Okay, so this one, what it is I'm using the function index of, and what I'm looking for is the position of a particular character. So in this case, I'm looking for a character that is a dead space. And the very first one, so it's the very first dead space, keep in mind, index starts with 0. So it might have said, we can see that it said that there were, let's see, 20 characters, okay? But that is actually index positions 0 through 19. So I'm explicitly asking for an index position of a character. So when I ask for the second one, all right, first one's easy, I get it straight out, but the second one, I have to then start at the position after the last index position. I don't want to start on that position because it's going to just return the exact same position it started at. So I move to position, so where's my sentence? Let me pull it up. I move to this position and then add 1, so now I'm here, and then I look for the next position. And of course it returns those individual positions. Now the next thing I said, okay, I want to be able to figure out the character at a particular position. So using the same sort of technique, the character at position 0, index position 0, well, that's just the very first one. That's going to be the. But now I want to find out the character at the next position. So we know that space 1 is going to be here, but I don't want to know the character there. I want to know the character here. So it becomes space plus 1, space 1 plus 1. And then go following that logic down the line, I then get the character at the beginning of each word. Using that same logic, I'm going to use a function called substring. And substring allows you to choose the beginning and ending of the index positions you want. Well, the very first word, the, is super easy. It's going to start at position 0. And then I just want to go up to the first dead position. Okay? So I'm going to take everything from 0 to the dead space and put it into a new variable. So that becomes variable word 1. Variable word 2, well, I'm going to start at this position. I'm going to add 1 to it. Okay? So now I'm here at the M, and I want to go to that position. So that becomes word 2, word 3, so following the same logic. I want to start here, add 1, go to this position. And lastly but not least, if I do not have this comma, it just goes to the end. So in this case, I went to this position, I added 1, and I went to the end, so that the last position, word 4, becomes the word cheese in this case. And in this case, All right, I wanted to find out exactly how many characters of a particular type there are, and this will be important for the next video. But it did take a little bit of manipulation, because you'll notice that there's a difference. A character is a single letter within a space. Okay, a character is a single letter. A string is a group of characters. Now, I wanted to be able to put in up here, I wanted to be able to enter any value that I wanted, whether it's uppercase or lowercase, and it to be smart enough to be able to figure out what it was I was looking for and then query the string for it. Let's not forget that the last thing we did was we turned the string into uppercase. Well, let me go up here. It turned it into uppercase. So we know all our letters are uppercase. I could have asked the user to please enter an uppercase value, but I just wanted you to enter any value. Well, there is no to uppercase that exists for characters. So what I did is I took and created a variable, okay, which I called the character of interest, and I incorporated it into the Arduino as a string. So even though it was only one letter, you could have actually typed several. It would have only looked at the very first, you'll see in a moment. But I took in that single character as a string. I then converted that string, which contains only one character, to uppercase. Then what I did is I said, well, alright, even if I put in more than one, what I want to do is I want to turn it into a character. So I created a character variable, and then I decided to look at the character at position 0 of this string. So even if there's only one letter in it, I now am going to be able to tell you what that letter is, and it's going to be a capital because I turned it into uppercase, and I'm going to stick it into a single character variable. And that meant that I could search for an individual character within a string by using this character at command within this loop, which is going from 0 to the total number of characters within this string. Every time it found one, it incremented the counter by 1, and we output the data here. Okay? So I hope that was sort of kind of clear. Again, what I did is I can only look at an individual character, right? So somehow I had to take data in and be able to convert it to a case because it was case sensitive. I had to do that by manipulating a string, and then I decided to query the string for its very first character and set that as a character variable, and then decided to look at each individual character within the string to see if it equaled, and if it did, the counter went up by 1. So hopefully this is a useful start for string manipulation, and I will see you again soon.